So chapter 8 is going to be done slightly differently than our other chapters have been done because I want to finish it before spring break so that you don't have the chance to forget things over spring break, but also so that our entire last 6 weeks can be trigonometry. So what I'm doing is I'm posting a video for every lesson in the chapter, and you can self-pace yourself through the chapter and follow the syllabus that's provided. I will also offer the opportunity to hear me teach it to you in class if you would prefer that, but I would recommend you bring your headphones to class every class period during the course of this chapter so that you can choose exactly how you want to learn the material, whether it's through videos or through me teaching it to the class. So before, you multiplied and divided and added fractions, and you factored polynomials. And if you don't have factoring down, now is the time to get it down. I've said this all year long. It never goes away. So you got to get it down. So now what we're going to be doing in this chapter is we're going to be simplifying rational expressions and graphing rational functions. Our new vocabulary is rational expression, which is a ratio of two polynomial expressions. So it's basically a fraction that has a polynomial in both the numerator and the denominator. And a complex fraction is a rational expression with a numerator and or a denominator that is also a rational expression. So we're going to get into some very, very ugly fractions in this section. Just a review of fraction properties because you tend to forget these if you haven't used them repeatedly. A common denominator is required for adding and subtracting fractions. Please remember, it is not required for multiplying and dividing fractions. Adding and subtracting fractions is far more difficult than multiplying and dividing fractions. And when I went to a math seminar years and years ago, about 20 years ago, they taught us the way not to teach how to multiply and divide fractions, but I actually thought it worked pretty well. And by this point, if you don't remember how to multiply and divide fractions, then here's the way to remember it, even though it doesn't tell you the why of anything. And it goes, multiplying fractions, that's no problem, just the top times the top and the bottom times the bottom. Dividing fractions, don't ask why, flip the second one over and multiply. So there you have your little ditty to help you remember how to multiply and divide fractions. And then remember that you can cross-cancel common factors when you're multiplying fractions. So to simplify a rational expression, you want to make sure that the numerator and the denominator are both factored completely. And so when I look at this, I realize that y squared minus 9 can be factored further. So I'm going to rewrite the whole thing. And y squared minus 9 will factor to y minus 3 and y plus 3. So now when I look at my numerator and my denominator, I see that I have the factor y plus 7 in common. And so I see that I can cancel those out. Now please don't make this common mistake of saying, oh, I see a 3 here and I see a 3 here. This 3 down in the denominator is actually part of a factor, and you can't cancel part of a factor. So you can't cancel 3 in this case. It would be a big no-no. So under what conditions is the expression undefined? So I just went ahead and wrote it instead of taking video time for that. In order to determine where an expression is undefined, you have to do that before you cancel anything. And if you think about where it's undefined, it's all based on the denominator can't equal 0. And if you happen to have a radicand, then that needs to be a real number. Now, we're dealing with polynomials, so we aren't going to have any radicands to work with. But in this case, if y equals -7 or 3 or -3, then this expression is undefined. So please always include the numbers that'll make it 0 even before you cancel. So I'm going to do this one. Go ahead and pause it and do this yourself, and then start it again and you'll see the answer. And there you have your answer. And we would say, if it had asked where it's undefined, we would say that it's undefined at -4, +4, and -5, because we have to include that even though it was canceled. For what value of p is the expression undefined? Well, we need to factor it, and we get p plus 3 times p minus 1 over p minus 5 times p plus 3. So this is going to be undefined where p equals 5 and where p equals -3, even though p plus 3 will cancel out in both the numerator and the denominator. You always have to look at the original one. So I'm going to do this one, pause it, and then see if you got it right. I'm actually going to pick up right here. So all I've done is factored out the greatest common factor in the numerator and the denominator. But when I see that I have y minus 3 and 3 minus y, and I'm looking at those saying they don't match exactly, but they're darn close, there's probably something you're going to be able to do with it. And when you have completely opposite signs, what you can do is pull out a negative sign, and I'm going to do it in the denominator. So we have x to the 4th times y minus 3. And then this, I'm going to say we have negative x to the 3rd, and that's also going to be times y minus 3. So basically what happened is I just pulled out a -1 in my denominator, and that changed the signs of both the y, which now became positive, and the 3, which now became negative. And so then that allows us to cancel y minus 3. Now we have negative x to the 4th over x to the 3rd, and we end up with just negative x. So multiplying rational expressions, we're just going to be using the typical rules of fractions. Multiplying fractions, that's no problem, just the top times the top and the bottom times the bottom. And then dividing fractions, don't ask why, flip the second one over and multiply, which is basically your copy dot flop. So multiply and divide this. So if we have 8x times over 21y cubed times 7y squared over 16x cubed, you can cross cancel. And so I see that I have the 8 will go into 16, 8 will go into 16 once, and 8 will go into 16 twice, and 8 will go into 8 once. I see that I have 1x in the numerator and 3 in the denominator, so this will become 1, and this will become x squared. I see that I have a 7 in the numerator and a 21 in the denominator, so I'm going to cancel that and make it 1, and this is going to become 3. And I have a y squared in the numerator and a y cubed in the denominator, so this is going to become 1, and this is going to become y. And so in my numerator now, I have 1 times 1 times 1 times 1. Well, that's just 1. In my denominator, I have 3 times y times 2 times x squared. And that's going to give us 3 times 2 is 6. And I'm going to put x squared y, because you should go in alphabetical order in this case. And that's it. So 10mk squared divided by 3c squared d divided by 5m to the 5th divided over 6c squared d squared. First thing we need to do is copy dot flop. So we get 10mk squared over 3c squared d times 6c squared d squared over 5m to the 5th. So I see that I can divide this by 5. 5 will go into 10 twice, and 5 will go into 5 once. I also see that 3 will go into 3 once, and 3 will go into 6 twice. I see that I have a c squared and a c squared, so those will both cancel out. I have a d squared over d, so this is just going to become d, and that one's going to go away. And I have x to the 5th, and I don't have any m's or k's or anything else. So I look at what I have left, and I have 2 times 2 in my numerator, so that's going to be 4. And then I have d m, well, actually, I guess I should do d k squared m. over x to the 5th is the only thing I have left in the denominator. So check your progress. I'm going to go ahead and do these. I would pause it and then see if you got it. So this is a great example of recognizing that this should probably have a -1 pulled out of it, as I did right here, so that you can factor k squared minus 1. And that factored to k minus 1 to k plus 1. And every factor ended up canceling out, and you simply ended up with -1. And there's your final answer on that one. So polynomials with a numerator and a denominator, this is going to be the same idea. We need to factor everything. And so you can factor everything and then copy dot flop, or you can copy dot flop and then factor. And I think I'm going to get the copy dot flop done. So I'm going to rewrite it as 2d plus 6 over d squared plus d minus 2 times d squared plus 3d plus 2 over d plus 3. So now to factor it, we get that this is 2 times a plus 3. And this one becomes a plus 2 times a plus 1. And this is going to be d plus 2 times d minus 1. And then we have d plus 3. So when we look at everything that'll cancel, and I'm realizing my d's are looking remarkably like a's, we have that d plus 2 will go away, d plus 3 will go away, and we have 2d plus 1 over d minus 1, and that's going to be as good as it gets. And you can just leave it factored. Now simplifying complex fractions. You have to work with each one individually, and I prefer to write this out as a division problem, because this is basically x squared over 9x squared minus 4y squared divided by x cubed over 2y minus 3x. So once you've written it like that, you see you just have a copy dot flop problem. So you have x squared over, and I'm going to go ahead and factor that 9x squared minus 4y squared now, because it's a difference of perfect squares. And so this here is going to factor to 3x minus 2y times 3x plus 2y. And then we need to dot flop, and so this is going to become 2y minus 3x over x cubed. And this fraction on the right hand side is already fully factored, so we can actually start canceling from here. And the x's are easy. We can see that we have x squared that's going to go away, and we're just going to be left with x in the denominator. Now we have, again, this case where we have factors that look remarkably similar but not quite. So if I pull out a -1 from my numerator, it becomes -1 times 3x minus 2y. And we're left with those red factors still and that purple x. So I'll put that purple x up front. And we have 3x minus 2y times 3x plus 2y. And we can cancel those. And so our final answer is going to be -1 over x times 3x plus 2y. You do this and then check your answer by my work. And there is your final answer for that one. And that's it for this video. That's section 8.1.